So we are going to be graphing quadratics in standard form. For the last 2 days, we've been doing vertex form. Pew, 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 pew. And in vertex form, we can see our A, H, and K, which tell us all of our transformations. Our A tells us if we have a rocks, and it tells us if we have vertical stretch or compression, and by how much. Now, notice that the A value is the same in our standard form and our vertex form. So it is the same A. Write that down. Okay, and then from our vertex form, we also know our vertex, our H and our K, which tell us our shifts. Has a T. Shifts has a T. Do we have H and K in standard form? Put your phone away.
What was the question?
Do we have H and K in standard form?
Yeah. Wait, no.
No. We have A, B, and C in standard form. Okay, so we have the same A, but then we have B and C instead of H and K. So when it comes to finding our vertex so that we can plot our vertex and then do our graphing pattern, we're going to have to do a little bit of detective work to find the H and K. Okay, so as you were walking in, I gave you all a reference sheet. The reference sheet looks like this. For the last 2 units, in units 3 and 4, I've only given you like this much of it, right? And then we had like some of this stuff whited out so it wasn't confusing, right? What? Did I not give you one? How did you sneak past me without one?
You're just a sneaky dick like that.
Everybody else get one? Like a magician ninja. All right, so notice that on your reference sheet, right here we have vertex form, and here we have standard form. Go ahead and label those. The other thing we're going to label on this sheet is kind of down toward the middle bottom. Okay, everybody stay with me. Do you see this monstrosity down here?
Yeah.
Okay, some of you are going to absolutely love this thing in Unit 6 because it works on all of our quadratics. This is the quadratic formula, and it is for solving quadratics. So I want you to label quadratic formula. It takes a little bit of practice to be able to use it correctly, but when you do get the hang of it, it works on everything. So you don't have to worry about, is this the right method to use? Because yes, it is. It works on everything. So that's nice about it. So the thing that's special about x-intercepts, if you remember, we kind of talked about this. If I have a quadratic, my x-intercepts are the same distance away from my axis of symmetry. I kind of drew that bad, but you get the idea, right? They have to be the same distance away from my vertex, right? My vertex has to be halfway in between my x-intercepts. Okay. So what this quadratic formula is doing, okay, so like, can you see that if I knew where my vertex was and I added a little bit, and I subtracted the same amount that I could find my roots. You guys see that?
Yeah.
That's what the quadratic formula does. It finds the x coordinate of the vertex, or the axis of symmetry. It's the same thing, right? They share an x. And then it adds a little bit and subtracts the same little bit. That's the plus minus. So it adds a little, takes away a little bit, and identifies those solutions. But are we solving quadratics right now? No. So we're not going to use this square root part until Unit 6 after we come back from break. What we're going to use is this little negative b over 2a that identifies the x coordinate, which is the h of our vertex. Okay, so that's what we're going to use. So flip back to your notes. From the quadratic formula, we get a cute little formula for our h value. Our h is the opposite of our b over 2a. And the a and b that it's talking about are these coefficients in our quadratic and linear terms of standard form. Sorry, hold on, look away for a second. My board's acting up. Okay, now, this is where it gets exciting. Once I have identified my input, can I then use my input, plug it in, and get my output to find the rest of my vertex?
Yes.
Yeah. Input, output, just like we did in Unit 3, way back when. So to find the K, we are going to plug in H to find K. So that takes care of our vertex. Remember that H is our input and K is our output. Okay, that's the plan. One last thing before we do an example. Okay, this is a really nifty way to make sure that you did it right. If you've done it right, your C value will match your y-intercept. Okay, that is a solemn vow. If you did it right, your C is your y-intercept, just like B was the y-intercept for a linear function. Okay, we're going to skip over example 1 and come back to it. I think next year I'm going to do example 2 as example 1. I'm going to change the order. But for right now, we'll start with 2. It's not easier, it's just easier to see what the A, B, and C are. And then once we get the hang of it, you'll be able to tell me what the A, B, and C are for the other one. Okay, so A is the coefficient for our quadratic term. So what is our A here?
0.5.
Yeah, the negative 0.5. Good. Okay, what is the B?
4.
Yeah. And the C is the negative 5. So the first thing we need is H. So H, we can find that using our little formula. Negative B over 2A. So what is our B? It's 4. So we want the opposite of 4. And then we have a 2, and then we plug in our A value, which is negative 0.5. Is this big enough where you guys can see it? I can zoom in. Let me zoom in a little bit.
No, it's not that it's too small, it's just the lights were flicking on the screen.
Oh, they were flickering? Okay. So what is negative 4 divided by 2 times negative 0.5? Okay, what's 2 times negative 0.5? Negative 1. What's negative 4 divided by negative 1?
4.
Yeah, 4. When I wrote the -1 over here, it looked like -1. So I don't know where to put it. There, that's better. I don't know. I don't know where to put it, guys. It's looking very stupid. Okay. Whatever. Okay, our H is 4, right?
Yeah.
Now we've got the H, now we need the K. So to get the K, we have to plug in the input to get the output. So our Y, which is going to be our K, is -0.5 times 4 squared plus 4 times 4 minus 5. Anyone feel like mashing this out with like mental math? Or do you want to use a calculator? Okay, I'm going to use a calculator. So -0.5
3.
times 4, close parentheses, square it, plus 4 times 4. What was it? Minus 5? Everybody getting 3? Make sure you know how to put in the calculator because they won't always be ones that you are going to confidently be able to do in your head. And you want to know how to be able to check your work. Can you put that phone in there quickly so that I don't have to be All right. Everybody got 3? Boom. Okay, so our K is 3. So now we have our H and K. We know that our H was 4. We plugged that in and we got a K of 3. I'm loving it. Okay, 4, 3, that's right here. Now, let's use our pattern. Our pattern says that if we go left or right 1, we can go up 1 because 1 squared is 1. If we go right or left 2, we can go up 4 because if I square 2 or -2, I get 4. 3 and -3 give me 9 when I square them. Okay, what do we have to do to our ups because of our fun little a value?
Oh, divided by -0.5. Or
You're really close.
multiply.
Yeah, multiply. So we're going to multiply by our -0.5. So we're going to chop it in half and change the sign. Half of 1. What?
0.5 to 4.5.
Okay, yes, but make them negative. So half of 1 is 0.5, and then make it negative. Half of 4 is 2, make it negative. Half of 9 is 4.5, make it negative. So that pattern will give me 6 more points after my vertex. So I can go left 1 down a half, right 1 down a half. Left 2 down 2, right 2 down 2. Left 2 down 4 and a half. Kind of had to think about that one. Left 3 down 4 and a half. Oh, I got my left and right backwards. It's fine. keep missing it. Okay, there we go. Okay, now it took me a few tries because it's tougher up here than it looks. But look at this y-intercept. As promised, my y-intercept is,
Negative 5.
yeah.
Oh.
Okay, what were our transformations?
Shift right was the 4 and up by 3.
Okay, so that one has to be the very last one we do, but we can write that down. Just put it at the bottom. Shifted right 4 and up 3 units. Okay, what was the first one?
There's no rocks.
What?
Or,
There it is.
There is. It's upside down like a frown. So we've got a rocks. All right, do we have a stretch or compression? Okay, by how much?
25.
Good. Vertical compression by 0.5, also known as a half. The negative is in the rocks. So we're just compressed by 0.5, not negative 0.5. They're independent of each other. Okay, any questions about that one? Okay, so after we find the vertex using the negative b over 2a and the unit 3 review stuff, it's just like what we've been doing for the last 2 days. Okay, the new part is just the negative b over 2a and plugging it in. We can handle that, right? Okay, perfect. Let's try number 1. We're ready for number 1. All right, look up at your standard form. How many terms are to the right of the equal sign? We got ax squared, we got bx, and we got c. Your standard form, right? 3 terms?
Yeah.
How many terms does this equation have? Only 2. So we've got a missing term. So let's see which ones we do have.
Doesn't have any idea.
Yeah, something is 0. So we have to figure out what. So, do we have an x squared term?
Yeah.
Okay, so we have an a. What's our a? Okay, negative 1 is our a. Okay, do we have a plain old linear x term? No, so that's the 0 that we're missing. So we have 0 x's, and then we have a plus 6. So the 0 is b, and the 6 is the c. Everybody happy with that?
Yeah.
Okay, you see why we didn't start with this one? I don't know why I put this one first. I must have been cuckoo choo. All right, so let's find our h. So we can get our h by doing negative b over 2a. So our b is 0, so we do the opposite of 0, which is still 0. And then we do 2 times our a, which was negative 1. So we have 0 divided by negative 2. You can ask your calculator over what it is if you don't know. Or if you think you know, but you want to make sure you're right, you can ask your calculator. What'd you get? 0. Okay. So my h for my vertex is 0. Now I've got my input to plug in. I can find my k. So we want y equals the opposite of our 0 squared plus 6. You see, I just used this rule right here. I just plugged in the 0. What's 0 squared? What's the opposite of 0? 0. So doesn't this whole thing just go away?
Practically, yeah.
Yeah. So what's our K?
2.
That is our K. Okay, now we're ready to start graphing. Our vertex is at 0, 6. That's on the y-axis. Now I can use my little graphing pattern to find a bunch more points. So if I go left or right, 1, I'm going to go up 1. Left or right 2, I go up 4. Left to right 3, I go up 9. Except, what's my A value? Yeah, if my A is -1, what do I have to do with that?
Turn all the ups to negative.
Yeah, I have to make all the ups downs. Or you can think of it as multiplying by -1. Okay, so it'll be a -1, a -4, and a -9. Okay? And you thought you weren't going to have enough room to graph it. I don't know if that's what you thought. I just made that up. Okay? So this is just our regular parent pattern, except it's flipped upside down. It's not stretched or compressed. This is only reflected and shifted up 2 units. Did this give us a min or a max?
Max.
Okay, we've got a max. So,
X is 0.
yep, at x equals 0, we have a max of
6.
6. Ooh, here's another fun thing. What did our C value promise us that our y-intercept should be?
That's what Thomas does.
Yep. All right, what is our axis of symmetry? What 0? 0 is just a number and I need a line. X equals 0. Okay, what about the domain? If I don't have any breaks in my graph, it's smooth and it goes on forever in both directions. All the real X values, good. All right, what about my range? Is it on and below my vertex or on and above my vertex? On and below. So my y values have to be what?
Equal to or less than equal to.
Okay, y is less than or equal to. Sorry, I meant to write y values. Y values less than or equal to 6. Okay. What about our solutions that we can estimate? What are our solutions? How do we find them? I'll give you a hint. There are 2 on this one. Yeah, the ones on the x-axis. Okay, so the solutions are the x values that make the y 0. So they come from our x-intercepts. They're just the x values, though, and we put them in curly brackets. So what's halfway between -2 and -3? Yeah, we can say like -2.5. It might be kind of more like -2.6, but this is an estimate, so I can say -2.5 if I want. And what's the other one? Yeah. Okay, what about my y-intercept? Close. 0, then 6. All right, flip it. Okay, we're not going to do all 3 of these. We're going to do 2. We're going to do this one and then the one at the bottom, because we already did one like number 4. Okay, so go ahead and identify your A, B, and C. A is in front of x squared, B is in front of x, and C is the little constant, the island in the stream. Okay, how do we find our H? What's our little formula? It's on the front of your notes, or you can look at the little quadratic formula that we boxed on your reference sheet. And it's the part that's not under the radical. I'm not going to tell you. You just sit here in this delicious, uncomfortable silence.
That's what I'm ready to.
Yeah. Negative b over 2a. Okay, so if our b is 8, negative b is -8. Our a is 2, so we've got 2 times 2 on the bottom. Okay, so we've got 2 times 2, which is 4 on the bottom. -8 divided by 4 is -2. So that's my h. Now I can plug that in. So my y is going to equal 2 times -2 squared plus 8 times -2 plus 7.
That's long,
Yeah, but your calculator will do that whole thing.
hopefully.
Okay, so it's 2 open parentheses -2 squared plus, was it 8?
Yeah.
8 times -2 plus or minus 7.
Plus 7.
Thank you. Make sure you know how to type it in. Because on test day and quiz day, I'm going to have amnesia, and I'm going to forget how to operate a calculator. I might not even remember my own name. All right, you should have got -1. Did you get it?
Yeah.
All right. Okay, so our K is -1. This is the H. Oh, here, I won't write it underneath. So our vertex is -2, -1 over here. Okay, let's use our little pattern. We go left or right. We go up. 1, 1, 2, 4, 3, 9. What's our A value?
-1. Wait.
A's are 2, so we're going to multiply by 2. So 1 times 2 is 2. 4 times 2 is 8. 9 times 2, 18. So those are our new ups. We're not going to be able to fit the 18, but we should be able to get the 2 and the 8. Make sure that every time you start at your vertex. Okay, if you did it right, your y-intercept should be 7. Or 0, 7.
Seems about correct.
Okay. Do we have a min or a max?
Min.
Min. So at x equals -2, we have a min of, what's the lowest value?
-1.
-1, and that came directly from our vertex, -2, -1. So is this new graph of ours, is it wider, narrower, or the same as the parent? Narrower. Okay, any questions about this one?
No.
All right, we're going to skip over number 4 and we're going to do number 5 because I want to practice drawing pictures. We haven't done that in a minute. And I think we skipped the picture one the other day. Okay, so the setter for the Capital City Cavaliers volleyball team sets the ball to a maximum height of 12.5 feet after it has flown a horizontal distance of 5 feet. Assuming the volleyball is set from a height of 6.25 feet, sketch a picture of the volleyball's flight path and identify the key characteristics. Who in here plays volleyball? I knew the answer to that. Do either of you want to attempt to set this tiny little ball or / get hit in the face? Woo! There it was. Oh, I dropped it. Well, you did your part. Thank you.
I did my best with the tiniest little ball I was given.
So I'm only like 5'5" 3/4", but you can imagine that would even be about the height where I would set the ball. It's over my head, right? So we're gonna start with our beautiful axes. Pew, 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 pew. Okay. Hey, here's me. Pew, pew, pew. That's actually how my body looks. My arms and my legs just stick out of my body. Okay. I'm setting the ball at a height over my head, starting at 6.25. Okay, it's going up to a maximum height and then coming back down. What is the maximum height?
12.5.
Okay, 12.5. How far does the ball have to travel horizontally until it gets to that height? That is correct. Now, we want to be a little bit careful. Do you see how we've kind of chopped off part of the parabola's flight path? So if this part, so from here to here is 5, and then from here to here is 5. But do you see that this whole thing is not 10? Do you see what I'm saying?
Yeah.
Okay, so we can't really tell the whole domain. So I'm sorry that that domain is on there, but we can do the rest of these. What is our vertex?
What, 12.5?
Close.
0.
X first. 5 first.
5.
And then the 12.5. Okay, so 5, 12.5. Do we have a min or a max?
Max.
Okay, so at x equals 5, we have a max of, okay, stop playing with the ball, 12.5. What is our axis of symmetry?
X equals 5.
X equals 5. Yeah. Okay, now we know where the domain starts. We just don't know exactly where it stops. Well, it does stop because the ball is going to hit the ground or be hit by another player. So it's going to start at 0, and then we don't know what this number is. So it's going to start at 0 and go pew, 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 pew. Okay, so it's going to be between 0 and what? Okay, and then we don't know what. Now we do know the range, and I think actually now that what is the lowest possible height for the ball if it hits the ground? 0. Okay, and then what's the highest height for the ball?
12.5.
12.5. So this is the range. It goes from 0 to 12.5. Okay, questions?
Nope.
Okay. You have 10 minutes for homework.
Yeah.
Booyah.
Even though your clock